Hello, I'm Anna Mackay and this video is on the standard normal distribution or a Z distribution. Here are some facts about that. We've already been talking about a normal distribution, so the normal curve, the bell curve as we call it. When we standardise it, it's a way of relating two different sets of data and comparing them, because if they've got different means and standard deviations, it makes it hard to compare. If we can create a Z-score, it helps to standardise them to compare facts about them. The formula for a Z-score is here. You take an X value, subtract the mean, divide by the standard deviation. What does this look like? So if we've got a normal distribution curve here, and we've previously talked about the percentages that lie within each standard deviation, either side of the mean. So as you can see at the bottom here, we've got the mean in the middle. To the right is the mean plus one standard deviation. And in terms of a Z-score, at that point in time, we would have 1. Mean has a Z-score of 0. Perhaps I'll write them up here. And each time around, each Z-score represents one standard deviation. So the next one to the right would be 2 and then 3. Now these are landing exactly on the standard deviations. Going to the left, we have -1, -2 and -3. Of course, you can have a Z-score of 0.7, 1.5, 2.2, all of those sorts of things, and negative as well. -0.5, -1.7, etc. So try and remember this visual as we're doing our example today. So Kelly scored 73% in history and the class mean was 68% with a standard deviation of 10.2%. In maths, she scored 66%. So instantly you might be thinking, well, Kelly scored less, so she's probably stronger in history than maths, and in comparison to the class mean for maths is 62 in comparison to 68. So again, a lower mean, and the standard deviation was 6.8. So less spread out than the history class. And so we're asked, which subject did Kelly perform better with compared to the rest of the class? So you might think, well, compared to herself, her higher score in history makes her better at history. But what if it was a really hard test in maths? Then her 66% might be quite good. So how can we work this out? I'm going to summarise those facts on this page here. So if we've got history and maths. So here is the summary of those facts and Kelly's scores. I'm going to graph this and in terms of a bell curve so that you can roughly see what they look like. It gives us a chance to talk about a few other facts in there too. I'm going to graph history first. So think about the mean for history, 68%. I'm going to put a dot there for that. Then I'm going to add on 3 standard deviations onto that and put 3 dots. And then I'm going to subtract off this 10.2 3 times. So I'm going to put dots at the 3 standard deviations. Then I'm going to draw the bell curve, which has a peak at the mean at 68%, and then it needs to drop down to cover 3 standard deviations, and the area under that curve will be 1. And after 3 standard deviations, you pretty much have to be at the baseline because 99.4% of the data has happened by that point. So there's our history curve, and I'm going to do the same for maths. Maths has a mean of 6.2. I'm going to put a dot at 6.2 and a standard deviation of 6.8. So if I add on 6.8, I get 68.6, and I'm going to go on and do that for all of them now. Now you'll notice that the standard deviation is smaller here. So essentially what that does to the bell curve is it pushes it up. If I want the area under the curve to be 1 and I keep the height of this curve the same as the black one, then the areas will not be the same. There'll be less under the purple curve. So to cover the same amount of area, I have to go up higher. It doesn't matter how high you go. This is just a rough sketch, but just trying to create that idea for yourself. I will put my peak up here perhaps, and now draw the curve. Now the next point to put on are Kelly's scores. For history, she scored 73%. So where is that on the axis? We've got it here at 73. I'll put a solid line for that's Kelly. And for maths, she scored 66. So that would be about here. Now let's try and anticipate the Z scores before we even work them out. There's a lot going on in these graphs, I do understand that. So think about history. The mean is this dashed line here. And where's the first standard deviation? Here, which would be a Z score of 1. Kelly scored in here at 73%, so what would her Z-score be? Something less than 1, about a half or 0.6 or something like that. What about maths? The mean is the dashed line here, and the next standard deviation along is this point here, and so I'll give that a score of 1. Where is Kelly's purple line there for maths? At 66%, again it's between 0 and 1. Looking a little bit more than halfway along. Let's work that out mathematically. So to work out her Z scores, we have Z, and I was always taught by my high school maths teacher to draw a line through the Z, otherwise it looks like a 2. We take her X score, which is the score that she got for history, which was 73%. You subtract off the mean, making sure you subtract off the history mean, divide by the standard deviation, and the Z score for that is 0.490. We tend to work to 3 significant figures, that's why we put that last 0 there. For maths, her Z score is, she got 66% for maths. You subtract off the maths mean of 62, divide by the maths standard deviation of 6.8, and that leaves us with 0.588. So what can you observe there? That her Z score for maths is higher, even though her percentage was lower for the maths test than it was for the history test. In comparison to the rest of the class, her score there is better than her score in the history class. Partly because the fact that the maths mean was 62, which was lower, but also the fact it's the standard deviation is smaller, so the scores are less spread out. So we finished that off with a sentence. It asked us in which class did she perform better. So Kelly performed better in maths compared to the rest of the class. I hope that's a quick introduction to Z scores, and it's quite handy to have that graph to visually anticipate what Z scores that you're going to get. The next video is on inverse normal, and we sort of go a little bit backwards in these Z scores. Thank you.